We learned about the inverse function of the sine last time. Remember what we learned last time? Hit the like button. Today, we'll delve into the inverse function of the cosine, considering the perspective of passing the horizontal line test. To pass the horizontal line test, we restrict the domain to 0, pi, resulting in a range of -1, 1. When symmetrical shifting is applied to this function with respect to the line y equals x, the inverse cosine function is graphed. The inverse cosine function has a domain of -1, 1, and a range of 0, pi, as constrained by the original cosine function. This relationship becomes evident when both functions are plotted on the same coordinate plane. Now, let's explore transformations of the inverse cosine function. Consider the graph of f of x equals negative cosine inverse of 2x plus 1 plus pi. Firstly, plot the parent function y equals cosine inverse of x. Secondly, graph y equals negative cosine inverse of x, representing a horizontal reflection across the x-axis. Thirdly, plot y equals negative cosine inverse of 2x, showcasing a horizontal dilation by a factor of 1/2. Please note that it is by a factor of 1/2, not by a factor of 2. You can see the appearance where the x values have halved horizontally. Next, graph y equals negative cosine inverse of 2x plus 1/2, representing a horizontal translation 1/2 units to the left. When factored, the coefficient 2 in front of x becomes 2x plus 1/2. Please note that it is 1/2, not 1. Finally, graph y equals negative cosine inverse of 2x plus 1/2 plus pi, which corresponds to a vertical translation pi units upward. As observed in the graph, the final function has a domain of -1, 0, and a range of 0, pi. Representing the transformation process of the graph on a single coordinate plane may appear somewhat complex. Many students find graphing inverse trigonometric functions challenging, but with a grasp of the restricted domain and range, understanding their transformations becomes surprisingly straightforward. See you next time.